Hi class, we continue our study in chapter 3 talking about systems of linear equations by moving into section 3.2. And here in this section what I want to do is I want to talk about algebraic methods for solving linear systems. So the two methods I'm going to be talking about is using what's called the substitution method and the elimination method. So substitution and elimination to solve systems. So we'll start with substitution and then we'll do an elimination one. Okay, so solving a system by substitution. So suppose we have these two equations here. Y is equal to x minus 1 and 3x plus 2y is equal to 13. Okay, well, notice from the first equation, we know the value of y is equal to x minus 2. So what I want to do is I want to take this. We know y is equal to x minus 1. Excuse me, I said x minus 2, x minus 1. So what we're going to do is we're going to substitute this in for y in the second equation. So wherever we see a y in the second equation, well, we know it's equal to x minus 1. So my second equation was 3x plus 2y is equal to 13. Well, I'm going to replace y with this x minus 1 here. And by making this substitution, we now have an equation in just one variable. Look, there's no two variables. It's a linear equation in one variable, so we can very easily solve this. So solving this equation here, you're going to distribute the 2 to get 2x minus 2. You're going to combine the 3x and the 2x to get 5x. You're going to add 2 to both sides. And then finally, you're going to divide by 5 here, right? You're just going to get x is equal to 3. So the x coordinate of the solution is 3. But now remember, a solution is an ordered pair, so you need both an x and a y. So to find the y coordinate, just substitute 3 for x in either of the original equations and solve for y. Doesn't matter which equation you do. I would pick the easiest one, which was y is equal to x minus 1. So you're going to plug 3 in for x because we know what x is. And you're going to get y is equal to 2. So you can see right here the solution is just 3 comma 2. Perfect. Piece of cake. Okay, so you can check this. That satisfies both the systems. The check is left to you. You can also check it with your graphing calculator like I showed you in the previous lecture, just plugging the two equations into your graphing calculator and then using the intersect option, and you'll see that the solution is indeed 3 comma 2. So to be honest, the calculator is often the easiest way to solve a system if you can very easily put it into that slope-intercept form. Okay, so to use substitution, solve a system of linear equations. First thing you're going to do is isolate a variable on one side of the equation. You're going to substitute the expression for the variable found in one, okay, the isolated one into the other equation. You're going to solve the resulting equation in one variable that you have. And then you're going to substitute that solution you just found into the one of the original equations to solve for the other variable. All right, let's do this one right here. So suppose I say solve this system of linear equations. Okay, so the first thing you're going to have to do to solve this by substitution is to pick a variable to isolate by itself. I think it's pretty straightforward. If you look at this x right here, you can get that very easily by itself by adding the 3y to the other side. So begin by solving for one of the variables in one of the equations. All right, if you can avoid fractions by choosing to solve for the equation of x in the first one. So as I said, you're just going to move the 3y over. So you're left with x is equal to 3y plus 4. So the next thing you're going to do is you're going to substitute 3y plus 4 for x into the equation 2 and solve for y. So when I do that, right, here is my original equation, or the second equation, 2x minus 5y is equal to 5. Well, I know x is equal to 3y plus 4. So wherever I see an x in that equation, I'm going to plug in 3y plus 4. You can follow the algebra here very easily to see that this single linear equation solves for y is equal to minus 3. Okay. So finally, what you're going to do is you're going to substitute the minus 3 you just found in for y, okay, in any of the equations. So I'll pick that x is equal to 3y plus 4. So I know my y is equal to negative 3. So I'm going to plug that right in for y, and I'm going to get x is equal to negative 5. So the solution that I just found is parentheses minus 5 comma minus 3 close the parentheses. So it's that ordered pair. So we could verify both your work by checking the order satisfies both the original equations, which it does, or you could plug it into your calculator. Okay, substitution is pretty straightforward. Now I want to talk about an elimination method. So if you have A is equal to B and C is equal to D, then a plus c, you're taking the left-hand side, is equal to b plus d. So in words, the sum of the left sides, the a and the c, of the two equations is equal to the sum of the right sides, b and d. All right, so what this means in practice to solve this system by elimination here. So solve this system. 4x minus 5y is equal to 3, and 3x plus 5y is equal to 11. All right, so if you notice just by looking at this, if you could just add these two equations together, you have minus 5y and plus 5y, you notice that those would go away. So by adding the two left sides and adding the two right sides of the equation, this is what we get. So basically, we're going to add down. So 4x plus 3x gets me 7x, minus 5y plus 5y, that just gets me 0, it's gone. And 3 plus 11 gets me 14. So having eliminated the y variable, okay, by adding down, we are left with an equation in just one simple variable. So next, solve the equation for x. So my resulting equation is that 7x plus 0 is equal to 14, or really just 7x is equal to 14. So divide both sides by 7, you get x is equal to 2. And so now you're going to just substitute 2 in for x in either of the original equations and solve for y. Again, doesn't matter which one you do. So I'll plug it into here, this equation, 4x minus 5y is equal to 3. So you get 4 plugging in 2 for x minus 5y is equal to 3. So you get 8 minus 5y is equal to 3. Subtract the 8 over, you get minus 5y is equal to minus 5. Divide by negative 5 on both sides, and you get y is equal to 1. So the solution here is 2, because that was my x value, comma 1 was my y value. Awesome. Another one that's not too bad. Okay, so to use elimination to solve the systems of two linear equations, if needed, and I'll do an example of this, multiply both sides by one equation by a number, and if necessary, multiply both sides of the equation by another number. Okay, so to get the coefficients of one variable to be equal in absolute value and opposite in sign. Okay, add the left sides and right sides, add down, like I showed you, of the equations to eliminate one of the variables. Solve for the remaining variable, and then substitute that solution into the original equation to find the other variable. Okay, so let's solve this system. So notice here I've got 4x minus 3y is equal to minus 3, and 5x plus 2y is equal to 25. So notice when you add down, none of the variables will cancel out. So what you're going to have to do is you're going to have to do a little algebra. Notice how here I have opposite signs. I have minus 3 and plus 2 for the coefficients among the y's. So you just think of what's the least common multiple of 3 and 2? And it's 6. So if I multiply this top equation by 2 and this total bottom equation by 3, all right, you're going to notice something. So to eliminate the y terms, multiply both sides of the first equation by 2, like I said, and multiply both sides of the second equation by 3. When you do that, 2 times all of this, you get 8x minus 6y is equal to minus 6. Multiply all of this by 3, you get 15x, 2y times 3 gets 6y. Now look what happens, is equal to 75. So the coefficients of the y term are now equal in absolute value and opposite in signs. Awesome. So what I want to do now is just add down. So next add the left sides and add the right sides. So when I do this, 8x plus 15x gives me 23x. 6 minus 6y plus 6y goes away. Minus 6 plus 75 just gets me 69. So you're just really left with 23x is equal to 69. Divide by 23, and look, you get x is equal to 3. Perfect, solved. So substituting 3 for x into one of the first equations, doesn't matter which one, you'll see that it simplifies to get 5. If you plug 3 into the other equation, you will also get 5, so it works perfectly. So the solution here is 3 comma 5. And the elimination method is really good. It's primarily used for problems that you see that are like this. Okay, if there's like an x or y by itself, just use the substitution. Okay. All right, so let's consider this one. So y is equal to 2x plus 1. That's equation 1 is y is equal to 2x plus 3. So the graphs of the equations are parallel lines, y, same slope, different y-intercepts. So the system we know is going to be inconsistent from the previous lecture, so there's going to be no solutions. And the solution set is an empty set. So what happens when you try to solve this by substitution? So we're going to substitute 2x plus 1 in for y in the second equation. And when you do that, this is what you get. 2x plus 1 is equal to 2x plus 3. So when you subtract 2x from each side, you're left with 1 is equal to 3. That doesn't make sense. So this is a false statement. Obviously, 1 is not equal to 3. So if the result of applying substitution or elimination to a linear system of two equations is a false statement, okay, the system is inconsistent. Okay, they're parallel lines, so the solution set is the empty set. Similarly, if you have a system that looks like this, y is equal to 2x plus 1, and 6x minus 3y is equal to minus 3. We saw this in a previous lecture. Okay, we know this is dependent, and the solution set is the infinite number of solutions. So what happens if you solve this by substitution? So wherever I see a y, I'm going to plug in this 2x plus 1. So when you simplify this, just going through, you're distributing the minus 3. You're left with something, when you simplify it fully, as minus 3 is equal to minus 3. And that's just a true statement. All right, notice how there's no variable left. It's just minus 3. Yep, that's equal to minus 3. So when you get a true statement like this, what this means, if the result of applying substitution elimination to a linear system of two equations is a true statement, so of the form A is equal to A, then the system is dependent. Okay, that is, the solution set of the ordered pairs represent every point on the same line. So they're the same line. So there's an infinite number of solutions. Okay, I'm going to stop the video here, but there's more to the slides. It just talks about solving by graphing and by tables, which I covered in the previous lecture.